Hello, hello. All right, yes, we're Math 111 OLC, winter 2012. We're in Unit 2. Today we're going to talk about Section 2.3 entitled Slope of a Line. What is the slope? Slope of a line. Well, it's a number. It's a number we can calculate for a given line that measures what I'll call steepness, somewhat informally, steepness of a line. So really I can compare the steepness of two different lines based on that number. I can easily calculate given any two lines. Alright, I'm sure we all know the slope. We've calculated it many times in our mathematical careers. Let me just for a minute delve into the background of the formula. If I'm given any 2 points on the line, and I'll call this point x2, y2. The subscript just is a label for that particular point. And I'll call this point x1, y1, a unique point, a different point. Again, the subscript 1 meaning just a label of that point. All right. What I can do is I can calculate, draw what I call here a slope triangle. I can calculate both the rise and the run of that line. Now let me erase this because I need some more room here. I should put this label up here. x1, x2, y2 be the coordinates of that particular point. I can calculate the rise, really the change in y level between those 2 points with the very simple subtraction y2 minus y sub 1. In other words, the rise of the line between those 2 points is nothing more than the difference in the y coordinates. Similarly, down here, I'm going to need that space here. Let me label the coordinates of this point over here. I'm going to call this point x1, y1. Similarly, the run between those 2 points, the distance of horizontal travel, is nothing more than the difference in the x coordinates, namely x sub 2 minus x sub 1. And we define the slope of a line, again labeled m, is the difference in the y coordinates over the corresponding difference in the x coordinates. Sometimes informally referred to as the rise over run. Alright, so given any 2 points on a line, I can always calculate the slope. Sometimes rise over run is denoted with delta notation, delta y over delta x, change in y over change in x. Alright, now I'm sure we've done this many times since our first algebra course. If I ask you to find the slope of a line through, let's say, minus 2, 4, and let's say 3, comma, minus 4. Again, this is an easy calculation. What I usually do is I let the first point given be x1, y1, and the second point given be x2, y2. Again, this formula, it doesn't matter which point you take as x1, y1 or x2, y2. It'll all come out in the wash in the end. Alright, so let me plug this in. So my slope is going to be y sub 2 is minus 4, minus y sub 1 is 4, over x sub 2 is 3, minus x sub 1 is minus 2. Be careful of the signs here. So in the numerator I end up with a minus 8, and in the denominator I get a 5. So that is an improper fraction, and it's already simplified, so I leave this as my response. The slope of the line through these 2 points is minus 8/5. If I was to graph these points, minus 2, 4, 3, minus 4, let me graph these and show you what's going on here. let's see, minus 2, 4. Puts me here. 3 minus 4. When x is 3, y is minus 4. Let me connect those 2 points, indicating the line through those 2 points. Let me label briefly the coordinates here. This point has coordinates minus 2, 4. This point has coordinates 3, minus 4. And I can indicate the rise and the run with what I call a slope triangle, basically breaking down the travel between those points into x and y components, or horizontal and vertical components. Well, you can easily see the run between these 2 points. Well, x goes from minus 2 to positive 3. Well, that's a positive 5 in run, in horizontal, positive horizontal travel, and by convention we say travel to the right is a positive horizontal travel. Okay? What about the run? Well, this point has a y-coordinate of 4. This point has a y-coordinate of minus 4. So clearly our run, should be labeled rise. Our rise is going to be, well, it's going to be a negative rise. We actually fall. And to fall results in what we call a negative rise. So the rise here is going to be minus 8. Alright, so the slope is nothing more than that ratio of rise, here it's negative rise, to run, or minus 8/5. Notice it's no accident that this is a negative slope, and anytime you've got a negative slope, that means your line is decreasing. Alright, negative slope implies decreasing line. Well, decreasing, again, with the convention of moving left to right in a horizontal sense. Right? Decreasing, going left to right. Alright, so that's our first attempt at slope calculation. Let's try another one. Find slope of line through minus 1, 3 and 2, 6. Alright. Again, you can take, labeling is totally arbitrary. You can label either point x1, y1, either point x2, y2. It all comes out the same in the end. My slope for this line is going to be y2 minus y1 over x2 minus x1. Careful of the signs here. 6 minus 3 is 3, and 2 minus minus 1 is positive 3. So my slope reduces to 1 over 1, which is 1. So a slope of 1. Let me graph these points quickly. And x is minus 1, y is 3. Let's be up here. When x is 2, y is 6. 1, 2, 3, 4, 5, 6. Puts me up here somewhere. If I connect these points, and forgive me, I'm a little crowded here. Let me erase this. Actually, I'm going to erase it all. The slope here is 1. You get a better graph of these points. Just give me a second. Alright, that's better. When x is minus 1, y is 3. Puts me there. When x is 2, y is 6. 1, 2, 3, 4, 5, 6. Puts me about here. So if I connect these 2 points, I can easily see that when I draw my slope triangle, my rise is going to be my difference in my y coordinates, namely 6 minus 3, and that's 3. My run is going to be the difference in my x coordinates, and 2 minus minus 1, that is also positive 3. And clearly my slope is going to be 3 over 3, or 1, which I calculated earlier. Notice 1 is a positive number. And it's no accident that when you've got a positive slope, you've got an increasing line, and by that I mean increasing left to right. Positive slope, increasing line. Negative slope, decreasing line, decreasing left to right. Positive slope, increasing line. Again, increasing means increasing from left to right. Okay? Let's talk about slopes of horizontal and vertical lines. What do I mean by that? Let's look at a horizontal line first. Well, as you know from our last section, a horizontal line is of the form y equals a constant. Y equals constant, horizontal line. Let's look at the line y equals 5. That's a horizontal line. Y equals a constant 5, horizontal line. If I make a quick graph of this, there is my horizontal line, y equals positive 5. Basically, it's a horizontal line with a y-intercept at positive 5. Now, I think you'll agree with me that a horizontal line implies that there is no rise, there is no change in the y-coordinates of any points on this line. Right? So that's equivalent to saying there is no rise or fall in any horizontal line. So if my slope is by definition rise over run, if my rise is 0, because I never rise or fall, no matter how much I run between any 2 points, 0 over anything is 0. So the idea here is a horizontal line will always have a slope of 0. Let me write that down again. Horizontal lines implies slope is 0. Okay? And nothing sacred about y equals 5 here. I could have said this for any horizontal line, because any horizontal line will not have any rise going left to right, etc. What about vertical lines? Well, as you know from last section, vertical lines have the form x equals constant. Well, let's look at the vertical line x equals 3 here. If I make a quick graph of the vertical line x equals 3, I can see, well, there's something somewhat similar happening in a vertical line. Well, just like a horizontal line had no rise, a vertical line will have no run. The x-coordinate never changes. So no matter how much of a rise you've got in y values, there will be no run in a vertical line. So if I try to calculate my slope, no matter what the rise is, the run will always be 0, and division by 0 is undefined. So that means in this situation where you've got a vertical line, our textbook uses this phrase, no defined slope. And if you look in the answer manual and the answer manuals I give you, they will use this phrase, no defined slope with regard to vertical lines. Okay? So let's do the rehash. Horizontal lines always have a slope of 0. Now please note that 0 is defined. 0 is a number. 0 exists on the number line. But vertical lines have, again, they'll use this phrase in this book, no defined slope. Okay? All right, let's talk about parallel and perpendicular lines. Yeah, let's see. I think I'm going to need a new screen here. Give me a minute. Get a new screen here. All right. Let's talk about parallel and perpendicular lines and the relationships of slope in those types of lines. All right. First, we're going to talk about parallel lines. What's the definition of a parallel line? Or lines that are parallel to each other? Well, I think you'll agree that parallel lines never intersect. That's the formal definition in the XY plane of parallel lines. And if two lines never intersect, I think most of you will agree with me. If I draw two lines that are parallel, well, because they never intersect, that means their ratio of rise to run must be the same. Otherwise, they would hit each other somewhere up or down the line. So parallel lines have equal slopes. And I think most students grasp onto that pretty easily. I can turn that into kind of math jargon. If line 1 is parallel to line 2, that implies the slope of line 1 equals the slope of line 2. That's kind of summarizing it in concise math language. Okay. What about perpendicular lines? Well, the definition of perpendicular lines is that they intersect at a 90-degree angle. Alright, so if line 1 is somewhere here looking like this, if I want to get a perpendicular line perpendicular to this, it would look something like this. Again, I would indicate a 90-degree angle between those lines with little square notation that you're familiar with. Alright, it turns out perpendicular lines have what they call negative reciprocal slopes. In other words, their numerical measures of steepness are negative reciprocals of each other. What does that mean? Let me give you an example. If line 1 has a slope of, let's say, -3, and if line 1 is perpendicular to some other line, I'll call line sub 2, then line 2 is going to have a slope that's the negative reciprocal of -1/3. What does negative reciprocal mean? Well, it means just what it says. It means you take the reciprocal and then negate it. So if I take the reciprocal of -3, that's going to be 1 over -3, and negate it. And of course, I'll want to simplify that. So M2 has a slope of 1/3. Alright, so if line 1 has a slope of -3, and if they're perpendicular, the slope of line 2 is going to be positive 1/3, negative reciprocals of each other. Alright, I want to work out a couple of homework examples of this type, homework exercises. I want to look at exercise 42 on page 157, so please familiarize yourself with that example. You might want to pause and turn to that exercise in section 2.3. Alright, they ask us in this problem, is the line through 6,4 and 8,5 parallel, perpendicular, or neither to a line with a slope of -2. Well, of course, we're going to make our judgment based on slope. What we got to do is find the slope of this line. So let me go ahead and grind that out quickly. Again, I'll do it y2 minus y1 over x2 minus x1. And if I punch that out, I get a 1 over 2, or m equals 1/2. Now, what's the story with comparing with the slope of -2? Of course, these slopes are negative reciprocals. 1/2 is the negative reciprocal of -2, and -2 is the negative reciprocal of 1/2. All right, so let me make a note of that. These are negative reciprocals of each other. And if slopes are negative reciprocals, that implies they are perpendicular lines. So your answer to this question should be a nice boxed perpendicular. Okay? We'll look at exercise 52 in the same list, same page. 52 in the homework list for section 2.3. Let me open up my book and get there. Let's see. Hang on, bear with me a minute. I want to be sure to read the problem correctly. 2.3, almost there. Alright, here we go. Determine whether the lines are parallel, perpendicular, or neither. Right? They give us two pairs of coordinates here. They've got a line through these 2 points, -5, 4, and 5, 4. And there's another line through two different points, -6, -2, and 3, -2. And we want to establish, are these parallel? Are these two lines parallel, perpendicular, or neither? Alright, now I suppose we could grind this out and compute the slopes of these two lines. Why don't we go ahead and do that? Let's take this top line here. The slope of the first line in the list is going to be y2 minus y1 over x2 minus x1. That gives me a 0 over a 10. Now 0 over anything is 0, so it turns out for this line, this first line in the list, the slope is 0. Alright? How about the second line? Well, it's going to be y2 minus y1 over x2 minus x1. I'll end up with a 0 in my numerator and a 9 in my denominator. Well, of course, that reduces to 0. and of course the numerator reduces to 0, and the slope is then 0. Alright, so if these slopes are the same, well, of course, then the lines are parallel. Now, I'm hoping you saw something happening here. It's an A there. I really could have come up with the answer right away without any calculation if I noticed something. If I look back at these lines, let's look at this first line, the coordinates given in this first line. Do you notice anything about those two coordinates? Notice the y value is the same. What does that mean? That means y is constant in these 2 points. And remember, when y is constant, you've got a horizontal line. Hopefully could have looked at that and found that out by inspection. Similarly, the second 2 coordinates on the second line. And you notice -2, the y coordinates of both points are the same. And again, y is constant. And when y is constant, you've got a horizontal line. So doesn't it make sense if you've got 2 horizontal lines that the slopes would both be 0 and that you've got parallel lines? So look for shortcuts like that when you can. Be observant. Look for things like constant x coordinates, constant y coordinates in the listing of particular points, and that may save you some trouble at homework or exam time. Alright, we're going to call it a day. We're reaching the 27-minute point. So I'm going to call this lecture on 2.3 done. Please be sure to review all homework problems and check your answers with the PDF files posted on Angels before attempting the online exams. Alright, section 2.4 is coming up, and that's it for 2.3.